Yes, please tell me what do you mean by beam? If anyone know, just tell me what do you mean by beam? Let me know what exactly you know about the beam, or what about your foundation, because this is only those who aware of this theory, they can easily solve the numericals, huh? Means in the complete numerical or complete unit, this every each and every word from this is very important. So you have to be very clear about each and every point. What is beam? So my first question to everybody is, what do you mean by beam? Please tell me. Anyone, you can ping in the chat box. Huh? This theory is very important. In the today's first lecture or first uh, session, I will just going to cover all those points in deeply. Please, diploma students, if anybody is there from diploma, you can unmute and you can tell me what do you mean by beam. Very basic question. Anybody? Sahil, Bagulom, Bagulom, am I audible? Give me a confirmation. Na? Everybody has to be very active. Bagulom, are you there or not?
Yes.
Can you tell me something about beam? Somebody has pinged me. Saurabh Devre, he is saying a structural element that primarily resists the load applied laterally. So laterally means what? Tell me the laterally means what? Struck me. Saurabh Devre, if possible, unmute yourself and tell me. This is very basic question. Everybody has to understand. Na? Everybody has to tell me. I'm not expecting copy paste. I'm expecting the foundation. If you know, then tell me. If you have seen beam somewhere, then tell me. If you don't know, then say sorry, sir. That's it. Just don't waste the time, because I've already 5 to 10 minutes I have spent for the net connection. Bagulom, do you know anything about beam? Bagul Om, do you know anything about beam? Anything. I'm not expecting in English. I'm expecting in any known language. तू हिंदी मराठी इंग्लिश कुठल्याही भाषेत बोल मला कळेल. नो. शीतल जगताप, can you? Shinde Neeraj, can you? When I'm asking the question, only that is the platform to aware you about the questions. I'm asking something means that is required for the numericals, that required for the further calculations. Shital Jagtap, can you tell me something about BIM if you know? Sonu Samsare, can you? Yes or no? Anjali संत काहीतरी बोला, कोणीतरी काहीतरी बोला. यस नो काहीतरी बोला. साइड beam is an object on which force load is applied to the beam. Then see, आप क्या बोल रहे हो साहिल? Beam is an object on which force load is applied to the beam. Again, I am asking the question: what is beam? You are saying it is an object on which the force load is applied to the beam. To the beam means what is beam? Again, the question is what is beam? What do you mean by beam? You are on the track, but you are missing something. Very good, well tried. Anjali Sant, Divya Ahire, Kalyani Chauhan, an element, Divya Ahire is saying an element designed to carry axial load. Okay, axial load. You are on the track, but you are not correct. Well tried. Good. Divya Ahire. then कुठे गेली ती गाडी? हा, कल्याणी चव्हाण, कृष्णा निकम, लक्ष्मण राऊत, निलेश कुवर, नूतन कचवे, नूतन नूतन कचवे, be active participant, be active participant in the lecture. हाँ. It is very good, Kalyani Chavan. It is a horizontal structural member which normally subjected to transverse loading. Okay, very good. I'm expecting this word, horizontal structural member. BIM, it is a horizontal structural member which is subjected to a loading. Divya, she has tell something like it is an axial load. It is a element which is used to carry the axial load. Axial load means the load which act along the axis, the load which act along the axis. But in case of beam, it is not the loading on axial direction. It is a loading in case of transverse. Somebody has told na ki lateral dimension. Somebody is saying that primary load applied in laterally. See, Saurabh Dev is saying laterally. Laterally means along the lateral dimension, not along the length, perpendicular to the length. So along the lateral dimension, it is subjected to loading. So the best example for beam is the horizontal beam or horizontal structural member in the construction. Horizontal structural member in the construction, that is the best example for the beam. Okay, so if I have horizontal structural member, let me show you. Let me show you. Do I have this structural member? I can say this is a horizontal structural member. If I do have such a type of the member, this is a horizontal structural member, this is a vertical structural member. When the structural member is in such a way, and if I'm going to apply load on the structural member like this, what does that means? This structural member carries a load of that. So whatever the type of load is this, let it be. But this is a horizontal structural member. Now this is a vertical structural member, and right now I'm going to again apply the structural member, copy, paste, I'm going to apply the load on that. So here it is an axial load. Here it is an axial load. Here it is a lateral load. So when the lateral load is carried by a horizontal structural member, but obvious if it is a horizontal structural member, it needs some support. So I'm going to give some supports to that structural member. So let us give some structural member. As this is a horizontal structural member which is subjected to that loading. So whatever the loading intensity is, let's say the loading intensity F, or say it is F. If F is a intensity, if F it is a intensity of the loading, and these two supports are there. So support that may we can say support is A. I'm going to give support as A, copy paste and support as a B. I'm going to do two different supports. Support A and support B. These are the two different supports that I have given. Means this is a horizontal structure member which carries a load. But as it is a structural member, it should not be hanging into the air. We have to give some supports to this. So this load has to be carried by two different supports, that is A and B. So when there is a horizontal structural member, that horizontal structural member which is subjected to loading, it is called as a beam. I guess the first point is clear to everybody. Beam. Now coming to the second point, that is what are the different types of the beam? What are the different types of the beam? Let us check what are the different types of the beam. If I'm going to discuss about the different types of the beam, so there are basically 5 to 6 types of the beam, but as far as our syllabus point of view, we are going to discuss on few basic important points, few important beams only as far as our syllabus point of view. First point is, first type of the beam is simply supported beam. Then second one is a cantilever beam. Third one is a continuous beam. Number 4 is a overhang beam. These are the 4 different types of the beam that we'll be looking for. Simply supported beam. In some question paper, it is denoted as SS beam or SS. Continuous beam, cantilever beam, and overhang beam. These are the 4 important different types of the beam. So, which beam is called as a simply supported beam? Which beam is called as a cantilever beam? Which beam is called as a continuous beam? Which beam is called as a overhang beam? That we'll be looking for. Okay. So, first beam, simply supported beam. Simply supported beam, the beam which is supported by two supports. The beam which is supported by two supports. A beam which is supported by two supports, and the supports are at the extremities. Simply supported beam. Cantilever beam. The next case is cantilever beam. This is a beam. This is the beam, and one end of such a beam is fixed. This is the beam, and one end of the beam is fixed. One end of such a beam is fixed. This is a beam. This is a horizontal structural member, and its one end is fixed, and another end is open or free. This is called as a cantilever beam. Now, third beam. Third beam is a continuous beam. Continuous beam is a beam in which there is a beam. There is a beam, a structural member, whose having support continuously. Number of support can be there, 1, 2, 3, 4, and so on. So there is a continuous supports are there. This is called as a continuous beam. Number last is a overhang beam. So overhang beam is a beam in which, let me draw that overhang beam. overhang beam. Overhang beam is a beam in which there is a overhanging section. Overhanging section is the beam which act as a simply supported beam, which act as a combination of simply supported plus cantilever beam. Now, why I am telling you the simply supported plus cantilever? Because from first point to this point, from first support to this second support, it acts as a simply supported beam. But from second point to the free end, it acts as a cantilever beam. My point is, my point is, my point is, basically, we will be looking for five different types. I'm going to revise. First one is simply supported beam. Beam means it is a horizontal structural member. So it is a horizontal structural member. Horizontal, 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 and this is a horizontal structural member. Carry the load. Carry the load. So I can give the load anywhere. So this is the load. I can give load here. I can give load here. I can give load here. Some anywhere. It is a horizontal structural member. In case of simply supported beam, two extreme ends are supported. In case of cantilever beam, one end is fixed, one end is free. In case of continuous beam, supports are given to them. In case of overhang beam, it is a combination of simply supported beam plus overhang that is cantilever. So first to second it is a simply supported beam, and second support onwards it is a cantilever beam. So these are the four different of the beams. Just give me an instant review. Just give me an instant answer. What are the different types of the beam that we will be looking for? Simple question, and I'm expecting simple answer in the chat box. Please tell me what are the different types of the beam. Tell me, type in the chat box. I'm expecting only types. Am I audible to everybody? Give me the answer in the chat box. Anyone? Anyone? What are the different types of the beam? Okay, Saildangi, Saildangi, he is very active. No? Simply supported, cantilever, continuous, and overhang. These are the four basic types of the beam that we'll be looking for. Very good, Sail. Now, the second point of the discussion is what is column? Column. So, as the beam is a horizontal structural member, in the same way, column is a vertical structural member. So, column is a vertical structural member. It is a column. As somebody has told me, I guess Divire has told, subjected to axial loading. So, exactly right. So, column is a vertical structural member subjected to axial loading. It is not actually, it can be axial, it can be eccentric, but the loading is in along the length. So here it is a column. Column is a vertical structural member which is subjected to loading, or which we can say it is subjected to axial loading. The point is vertical structural member is important. Okay. Next point of discussion is, I guess, column and beam. Both are clear to everybody. The next point is supports. What are the different points? What are the different supports? Supports. So there are 3 to 4 types of the supports we'll be looking for as far as our syllabus point of view. They are namely, first is a roller support. Roller support. Second one is a hinged support. Hinged support. Fixed support. Then then roller hinge sliding support is there, but that is not in our syllabus. Roller support, hinge support. Okay, these 3 supports we'll be looking for. Roller support. Let's have a look. So whenever the roller support is there, the indication of roller support is just like this. There's the triangle, and it is followed by which is the roller support. In case of roller support, in case of roller support, reaction is always normal to contact surface. Means what? This is a roller support. This is a roller support. In such a case, the reaction is always normal to the contact surface. Means this is a diagrammatic representation of the roller support, but this is nothing but that. If I'm going to draw some beam over there, so this is a beam. The meaning of both is same. The meaning of both is same. The roller support is nothing but a normal support. Reaction is always normal to the contact surface. This is very important. These things we required in future. Second, hinge support. So hinge support, the indication of the hinge support is like is a hinge support. But when there is a hinge support, when there is a hinge support, here it is like this. Discipline. The direction of application of reaction is in such a way. Okay. So what does that means? One is a horizontal and one is a vertical. Whenever we are calculating, sometimes very few times we record forces acting along the x direction, but mostly we are neglecting the forces acting along the x direction. What does that both sign indicate? The indication of both the sign means restriction to the movement. Means restriction to the movement in x and y Direction. What does that mean? Restriction to the movement in the x and y direction means only these supports are reliable to fix this. In such a case, it can has movement. It can move in that direction. It can move in clockwise direction. It can move in anti-clockwise direction. But when there is the hinge support, it is not allowing any kind of movement to act in the x and y direction. This will be clear to you during the numericals. Okay. This will be very clear to everybody during the numericals. But right now, try to understand. Hinge support stands for two different types of the supports are acting on the beam. Two different types of the supports are acting on the beam, which prevent the beam to produce movement in x and y direction. That's it. Fixed support. Now, fixed support. The indication of fixed support is like there should be movement. Let me draw movement. Let me draw the movement. This is the one axis. Let me draw beam directly over there. There is beam. There's a beam, and such a beam has the different types of the reaction in vertical and in horizontal directions. In vertical and in horizontal direction, along with the application of movement. So where is the movement? Yes, I got it. There is a movement. X-axis, y-axis, and the movement. So in such a case, the arrow indicates the restriction to the movement in respective directions. Means in case of fixed supports, in case of fixed support, both the arrows are indicating that in any respect the movement are restricted. Like hinge support, there is no movement in x and y direction. Similarly, even though there is application of movement on the beam, even though there is application of the movement on the beam, still there is no any kind of the movement or no any kind of the movement will be acting on that because it is completely fixed. Try to understand. I'm repeating. We'll be talking about three different types of the support. One is a roller support, second one is a hinge support, and third one is a fixed support. Roller support, roller support is nothing but it is a simply support. It is just a support given to the beam, and its reaction is always in normal, means in vertical direction. Normal means in vertical direction, just like show along y-axis. Means it that beam, if the forces are acting, a forces or movement will act on that beam, there will be a movement in x y direction or in any direction as per the application of the movement. Second support is hinge support. Hinge support is the support in which it prevent or there is a restriction to the movement in the x and y direction. X and y directions, there will be no any kind of the movement. So z direction will be there. So it is possible if the load is given to the beam, it can twist or there will be movement in the z direction. Third type of the beam is third type of the support is fixed support. In that support, there are the restriction given to the beam in such a way that even though there is a forces acting on the beam and the movement are acting on the beam, still there is no any kind of the movement act on the beam, even though the movement is acting on the beam. Okay, so there are three different types of the supports that we have seen. Just give me a confirmation. Okay, very good. Just give me a confirmation. What are the three different types of the support that we have seen right now? Just give me a confirmation in the chat box. Just give me a confirmation in the chat box. What are the different types of the support that we have seen? Krishna Nikam, ruler support, hinge support, and fixed support. Very good. Kalyani Chavan, very good. Krishna Chavan, Krishna Nikam, very good. Divya Iyer, very good. Okay. Now moving onwards. Now the next point is load. The first two, three is clear. Now load. Loads. So what are the different loads that we'll be looking for? So as far as our syllabus point of view, we'll be looking for different types of the load. Can anybody tell me what are the different types of diploma students? Huh? Can anybody tell me what are the different types of the load acting on BIM? Might be you have solved numericals. In that case, you have observed, sir, this is the load, this is the load, and that is the load. Anybody? Very good. Rushikesh Ahir. Anybody? Anybody can tell me? Rushikesh Ahir, very good. Very good. Nilesh Kuar, nice. Please tell me type of load. Okay. No. Let's have a look. Somebody is saying something. No? UDL, UVL, and fixed load. Very good side. Very good side. So as per size opinion, there are three different load. Let me copy the size load and let me put it into the slide. So there are different loads are there. So there is a first type of the load is called point load. Second load is a UDL, that is uniformly distributed load, and that is UDL, that is called as a UDL. And the third is a uniformly varying load, that is U, V, and L. So, uniformly varying load, uniformly distributed load, and the fixed load is your point load. These are the three different types of the load acting on the BIM. So let us calculate how to calculate their intensity that we'll be looking for. Okay. So first case, if there is a BIM, if there is a BIM and on that BIM there is a load is acting. So somewhere I have put the value of force. If there is a BIM, if there is a BIM, if there is a BIM which is subjected to a load, if there is a BIM which is subjected to a load, and say the intensity of that loading is F. Intensity of that loading is F. If the intensity of that loading is F, so we can say the beam is subjected to F point load. F point load, or we can say F kilonewton of load. Simply, how much intensity of the loading on that beam? If that is point load or fixed load, we can say the intensity of loading is F. In case of second, uniformly distributed load. If there is a uniformly distributed load is there, what if uniformly distributed load is there? Similarly, when there is a uniformly distributed load is there, and if the beam is in such a way, and if I draw uniformly distributed load over there, over here, so copy. If I draw the uniformly distributed load over there, so this will be the uniformly distributed load. This can be a, this is the uniformly distributed. This is the uniformly distributed load. If such a load is there, such a type of the load acting on the beam is there, means this is a beam, and if such a type of the loading is observed on the beam, its intensity is given in terms of, say, F kilonewton per meter. F kilonewton per meter. It would be the, it is the intensity of that loading, and if it is having a length of L, if it is having a length of L, L is the length of that beam. If L is the length of that beam, so how much intensity of that load? Then the intensity is equals to, the intensity of the loading will be equals to, intensity of the loading will be equals to intensity of load of load will be equals to your F into L. That will be the intensity of the loading. And if somebody has asked you what is the location of intensity, it is equals to L by 2. Okay. First question is, if it is a uniformly distributed load, it is having the intensity of F kilonewton per meter. In that case, if it is having the intensity of F kilonewton per meter and length of L, in that case, how to calculate its intensity? The intensity will be equals to force into its length. And what is its location? What is the location of acting of intensity? So its location is L by 2, half of the total distance. That is the intensity. Now third case. Third case. Third case, if there is a uniformly varying load. So let me draw uniformly varying load. Uniformly varying load. This is the beam. This is the beam. And let us have uniformly varying load. This is the beam, and it is having the uniformly varying load as this much. So this is blue color is the beam, and this is red color is the uniformly varying load. So if I say the intensity of that varying load is varies from varies from varies from best 0 kilonewton to F kilonewton, minimum to maximum. So this is inclined line indicate that the intensity of the loading will be increased. So here it is 0, here it is something 1, 2, 3, 4, 5, and 6, so on. So the intensity of the uniformly varying load is varies from 0 to F. So how to calculate its intensity? So let us calculate its intensity and its location of intensity. How to calculate its intensity? So the intensity of the loading is nothing but area under the triangle. So how to calculate area under the triangle? So half area of the triangle is nothing but 1 by 2, half into length. Say it is having a base of length L. half into width, it is f. So f half into this is the length, half into length into width, it is f is the intensity. So it is the total intensity. Now, what is the location of intensity? So right now we have two location. If it is L by 2, it is from left hand side, it is from right hand side, both will be the same. But what if it is a triangle? So it is having a different intensity. From 0 kilonewton intensity, location of intensity, from 0 kilonewton, it is from 0 kilonewton, it is 2L by 3. From 0 kilonewton, it is 2L by 3. And similarly, if we move from maximum, it is L by 3. So what is that? It is nothing but it is the location of centroid. So location of centroid means if we need to balance the axis, if we need to balance this structural member, in that case, there would be a CG somewhere here. There would be a CG somewhere here. So the distance of that CG from left hand side is 2L by 3 and from right hand side it is L by 3. And it is nothing but the point where whole mass of the body is supposed to be concentrated. So just it is 10. आपका EMM का लेक्चर कब है बताओ? EMM का लेक्चर कितने बजे? तुमचा EMM का लेक्चर किती वाजता आहे?
11:30.
तर म्हणजे आता एक लेक्चर आहे का दुसरं?
हो.
आता कोणाचं लेक्चर आहे?
पाटील सर.
आता कोण? Okay. Okay. I'm going to stop over here because it is 10:37 now. The third lecture will be continued by myself. Okay. Thank you so much. Have a good day. Have a great day. Somebody is waiting for you. So please join that lecture. And after that, I'll be connecting you at 11:30. Thank you so much.